think what we need is like a signal. No? Okay. Okay, good evening, ladies and gentlemen, our viewers from around the world, and good evening, my distinguished colleagues and friends. Today, I'm very, very pleased to be conducting this lecture, the topic of which is entitled Knowledge in the Age of Artificial Intelligence. Now, this is obviously a vast topic that encompasses many, many different domains of knowledge. However, this is at the center of what it means to pursue the research and activities of artificial intelligence. Why is that? Well, let's begin with the question of what is knowledge, right? What does it mean for us to know something? And how do we, as it were, formalistically model, how we produce and acquire knowledge? And can this be replicated computationally on a machine, for example, right? Now, these are some of the questions that were originally asked by some of the forefathers of AI, such as Herbert Simon and Alan Newell at Carnegie Mellon University. In fact, before the famous conference in 1956 at Dartmouth College, where some of the other forefathers, if you will, gathered in order to jumpstart, formally start the field that is now known as AI. Alan Newell and Simon wrote a paper known as The Logic Theorist, which was an attempt at capturing, how a logician or a mathematician would arrive at a theorem. And they replicated a great deal of, proofs that were, proffered in Bertrand Russell and Alfred North Whitehead's Principia Mathematica. Now, some of the earlier efforts were expert systems, again, to capture how an expert goes about amassing knowledge and making inferences and making connections and arriving at a certain conclusion. So, for example, whether it be, a medical diagnostic, for example, or a prescription for a drug. And some of the other earlier efforts had to do with, for example, playing the chess program. So the famous Deep Blue was, at IBM, was based on deep thought, again, by Simon and Newell, in an effort, for example, to replicate a domain-specific knowledge. So the earlier efforts were very, very domain-specific and was an effort to replicate sort of the knowledge production and also inference processes. And in some ways, that got overshadowed by the subsequent development known as machine learning. Now, if the earlier efforts were to formalistically, computationally capture these domain-specific knowledge and inference processes, machine learning became a lot more general, if you will, right? So in some ways, we gave up on the idea of trying to capture that formalistically and symbolically. But in some ways, we went sort of a level lower in terms of organization of knowledge or organization of AI, if you will. It superseded, if you will, this symbolic efforts. However, the common thread of knowledge remains. The clue is in the title of this endeavor, machine learning, right? So, instead of capturing formalistically domain-specific knowledge, we're trying to now teach machines to learn stuff, to acquire knowledge, right? Therefore, knowledge is at the very heart of AI, and It's a tremendous pleasure to be able to discuss this, something that is very stimulating at the same time, very close to my heart. So we'll be discussing some examples of AI that are germane specifically to knowledge, both in terms of generation of knowledge and acquisition of knowledge. And things such as COVID-19 vaccine discovery, drug discovery, for example, and linguistic knowledge, processing, for example, by way of machine translation, and finally, the greatest or the most advanced iteration of such effort, known as GPT-3, and what that implies, as AI moves forward. So we have in our midst a distinguished lecturer, guest, Dr. Sanjay Nadkarni. Welcome. And Dr. Sanjay Nadkarni and myself were interesting animals. We were both trained originally in theoretical physics, and we have a way of looking at the world. And we had interesting journeys, and we ended up both in social sciences, if you will. But we both started off in natural science. So he will say more about that later on. And he's had a distinguished career, both in natural sciences and also at the Asian Development Bank. And he worked in several think tanks, and also at a UN agency, particularly germane to our topic today, on knowledge management. Okay. So interesting fact that I'd like to impart upon our audience is that he spent a great deal of time in Moscow, and did his studies in Moscow, and is fluent in Russian. So it falls upon me to welcome our lecturer, Dr. Sanjay Nadkarni. Dobry вечер, and the floor is yours.
Thank you, Dr. Stephen, for your introductions. I would also like to extend my heartfelt thanks to Trends for inviting me for this guest lecture. And I hope I'm able to do justice to this topic of knowledge in the age of artificial intelligence. So just to touch upon what Dr. Stephen mentioned about the journey from natural sciences to social sciences. If I may, maybe I could just present my screen. I don't intend to impose death by PowerPoint, but I just have some screens. I don't know if the audience, if you're able to see my screen, is it
Yes.
on live?
Yes.
Brilliant. Okay. Okay. Just a bit on my journey from pure sciences into social sciences. The mathematical tools are more or less the same. However, there is one distinguishing factor. In natural sciences, all particles in physics that we study more or less behave the same. All electrons behave in the same way. All subatomic particles behave in more or less the same way. However, human nature is different. So when you try to use these mathematical tools to model human behavior, it's actually a bit more challenging than it is in the case of natural sciences. So this was something pretty exciting that I found when I transitioned from the natural science domain into social sciences. So modeling human behavior, is it possible? Is it doable? Is it necessary? Are humans predictable? So these are the questions. I mean, this has been going on. This is philosophically for millennia now. Now, with technology, with the aid of technology, with the advances in artificial intelligence, do we have the capability to come a trifle closer in achieving that goal? So that's the big question mark. Obviously, when I transitioned into this domain, AI, the way it's used now, wasn't as widespread. And over the years, what I've noticed is if we had these same tools at our disposal, when I was involved with some interventions, as Dr. Stephen mentioned, with the ADB, with some of the UN agencies, the impact would have been way more different than what we managed to achieve in those days with what we would now consider more primitive tools. This is about a decade and a half ago. So the key differentiator between individuals, societies, and nation states, coming back to a topic of knowledge, is the knowledge disconnect, knowledge deficiency, the asymmetry, if you will. So, sorry, let me, I don't, okay. There's some issue with my PPT. Okay, I think this should be fine. Yeah. Dr. Stephen, just let me know if my screen goes, because I'm on a dual screen, so hopefully it should
that's
be
fine.
okay.
Yeah,
right.
we can see it. Yeah.
Great. So at a macro level, the growing contribution of intangible capital in the total productive wealth that is being created, which is essentially a function of GDP per capita, and how it's distributed, which is what we would call the Gini coefficient from an econometric's perspective, is a pointer to the emergence of a knowledge economy. So the past couple of decades, there has been a trend towards transitioning into a knowledge-based economy. Many countries have adopted this as their priority. We've seen the UAE make massive strides in the last few years, jumping leaps and bounds in various league tables. The UN, its affiliated agencies, the Bretton Woods institutions such as the World Bank, the ADB, the World Economic Forum, and other multilateral entities are heavily invested in terms of their focus on the subject of knowledge, or a knowledge-based economy more precisely. So the World Bank, for instance, in its Knowledge for Development, I think it was called K4D, Knowledge for Development Initiative, had identified 4 enablers for creating and sustaining such a knowledge-based economy, right? It's economic incentive and institutional regime, education, ICT, because it was then still the classical ICT, and an innovation ecosystem. So when we have such a lot of focus from intergovernmental agencies on a knowledge-based economy, you can just see the value that has been associated with knowledge, or rather having the knowledge to solve society's overarching problems. So let me move on to the next slide. Before we delve into the socioeconomic impact of knowledge on individuals and societies at large in a contemporary context, let's reflect on what exactly is knowledge, just from a semantic perspective. So knowledge can be described as an intellectual understanding of a concept, topic, or situation, or a familiarity with it. On the value addition spectrum, organizing raw data into information and then treating this information to extract understanding is what characterizes knowledge. So knowledge can be grouped into 2 categories, explicit and tacit. This is important for us to understand, because when it comes to the application of technologies, AI, which we will talk in a bit, this distinction becomes pretty important. So while explicit knowledge is documentable, archivable, and retrievable, tacit knowledge is defined more by personal experiences, trial and error, interaction with society at large. So it's difficult to kind of, structure it in a way that is easily documentable and retrievable. So when it comes to explicit knowledge, the mass adoption of ICT, or information communication technologies, which was identified as one of the pillars by the World Bank, as I mentioned a while ago, drivers, sorry. So the mass adoption of ICT in the last 2-3 decades has given a great fillip to this structured aspect of knowledge. So lo and behold, knowledge could be perceived as being manageable with the help of technology. So this gave rise to the concept of what we now call knowledge management, which is essentially an interdisciplinary field that features cognitive sciences, epistemology, and psychology. So just to put this into perspective, what you see on the screen is a knowledge pyramid, and effectively where technologies have been deployed, the what I would call pre-AI technologies, if you will, or ICT, traditional information and communication technologies, have been geared more towards managing this sort of explicit knowledge, right? These technologies are not suitable or not capable of looking at the tacit element. And that's where we will link it with AI as we move along the discussion. So now, having put the concept of knowledge, tacit, explicit, into context, let us take a look at the socioeconomic impact of knowledge, right? So in terms of the socioeconomic implications from the perspective of a knowledge paradigm, on the basis of the premise that information asymmetry, which we talked about later a while back, perpetuates a vicious cycle of economic deprivation, poverty, which can often lead to conflicts in many cases. The hypothesis that I would like to make is that knowledge flow mechanisms subsumed into socioeconomic value chains can serve as an effective instrument in poverty alleviation and hence conflict mitigation efforts as well. So in this case, what is important is capacity building and last mile connectivity. These become critical for such knowledge-driven interventions, and the need to be studied from the perspective of the zeitgeist of what we now call the fourth industrial revolution, or Industry 4.0. So the first industrial revolution started with the steam engine, and today we are in what is called essentially the fourth industrial revolution. And AI, IoT, big data, blockchain, these are all sort of elements or pillars, if you will, of the fourth industrial revolution. So the point I'm trying to make here is the last mile connectivity on the knowledge highway is the critical block for ensuring that knowledge can be harnessed for good when it comes to economic development, poverty alleviation, addressing the information asymmetry, essentially. Dr. Stephen mentioned my work with some of the multilateral agencies, specifically the Asian Development Bank and UNESCO. I'll touch upon that, but it's important for us to put this within the context of Industry 4.0, because when I was involved with these agencies, when I did my work, this was, I'm talking about a good decade and a half ago, the Industrial Revolution 4.0 was not yet in vogue. There were no smartphones, there was no mobile data, right? So essentially, the work that I did was more in the context of the old ICT framework. And hence, from a knowledge perspective, it was about dealing with explicit knowledge. The downside of it is the inability to harness the tacit element was always something that remained as unfinished business. Okay, so fast forward 2021, if the same tools were available for those type of interventions that we have now access to, things would have been quite different. So just on that brief note about my work at ADB and UNESCO on the role of technology in poverty alleviation effort, I published an academic paper on K-credit. This was the phrase or a model which I coined. It stands for knowledge creation, retention, exchange, devolution, interpretation, and treatment. Again, as I said, this work was done in an era preceding the availability of end user AI tools and compute power at scale, which we have access to today. So it would always be of interest to see how these interventions can be replicated with the tools that we have today. What benefits that can hypothetically can accrue, which I couldn't achieve with the available technologies in the pre-industry 4.0 era, or essentially using classical ICT. I know classical ICT almost sounds like an oxymoron, but it is what it is. Because today in the age of industry 4.0, using those type of technologies almost seems like, oh, okay, this is Stone Age stuff. Okay, I know this is a bit of an exaggeration, but just for the impact, right? So the ability to use AI at scale is something which I think society can put to good use. There's a lot of discussion that can be spun around this. There's lots of verticals, lots of sectors that can benefit through the usage of these AI tools. And again, that brings me to the tacit element of knowledge, because AI is capable of handling that element. This was something that classical ICT, as I mentioned before, was not capable of doing. So coming back to the Industry 4.0 pillars, incidentally, this work that I did was essentially focusing on tourism, the application of K credit within the context of poverty alleviation in the domain of what is called pro-poor tourism, or tourism for the benefit of the poor. The idea was to equip people in economically disadvantaged geographies, particularly in the rural hinterland within the APAC, Asia Pacific region, to look at tourism as a source of supplementary income to their otherwise subsisting farming or other agricultural activities. And in order for them to achieve this, and this is important to note, it was by no means meant to be a substitute, but purely to complement the activities that they were engaged in. This was particularly for those who were living what we call below poverty line, or PBL. In those days, the benchmark, I think, was $1 a day. So the ability to get supplementary income through technology-related interventions where knowledge could be sort of created, retained, exchanged, the K credit, devolved, interpreted, and treated. That's where the whole focus was. Obviously, this is using the latest technology that was then available. We still had downloaded the versions of software. Cloud computing was pretty much in its infancy. There were no smartphones. There was no mobile data. So just having an internet connection was considered something, oh wow. Or having a website, for instance, was considered, oh wow. Today we take this for granted, right? Even a school child can develop a website today. My 11-year-old daughter does that. So, I mean, the point I'm trying to make is we take things for granted so easily, but when you retrospectively put yourselves in that context where that technology was then available, which was then considered latest and wow, and what could be achieved with those available tools, you can only see if the similar interventions, and I'm sure there are such interventions going on. The only question is whether these technologies that are now available are being harnessed. So that is the big question mark. So for instance, AI at scale, when it is used for predicting weather patterns, market pricing, yeah, that is what AI is capable of dealing with. Mining sentiment, we'll talk a bit about that later when we talk about GPT-3. So things like, for instance, mining sentiments is accessing or harnessing tacit knowledge. This is something that a traditional structured ICT framework cannot possibly achieve. Just the scale and the complexity won't allow that. Yeah. So that was just to put into context. I mean, this was published as an academic paper. I've given the reference here. This was based on my work essentially with the ADB and UNESCAP as a kind of a framework. So this K-credit was developed, as I said, in the good old days, preceding Industry 4.0. And now, as Dr. Stephen mentioned, I'd like to touch a bit upon GPT-3. AI, big data, blockchain, Internet of Things, simulated reality, robotics. These are essentially the drivers of the fourth industrial revolution. So seeing AI as a standalone would not do justice to it. We have to see it as an entire ecosystem of Industry 4.0, or the fourth industrial revolution. So we live in an age where data is said to be the new oil. Well, at least in crude form, right? Because data is just raw, it's not of much value. So until the dawn of the digital era, we lived in a data deficient world. Accessing, capturing, storing, analyzing data was both difficult and expensive. Today, we are data rich, for sure. There's lots and lots of data. Yet, we are knowledge poor. Because a lot of this data sits in a raw format. So it's just like having crude oil, which has not yet been extracted. And this knowledge poverty, as we experience in this day and age, is where AI comes in. Because traditional technologies are just not suited to handle this large, immense volume of data. Often it's called big data, and typically it's characterized by the so-called V's: volume, velocity, variety. There are other V's as well, but these were the three original V's. There's veracity and quite a few other V's that researchers came up with later as concepts. So, as I said, today we are data rich, yet knowledge poor. And how can AI address this issue? So AI is particularly helpful when there is some sort of an intelligent judgment to be made, and where there are many of these judgments that need to be made simultaneously, in real time, continuously. Yeah, this is something that is not humanly possible. No human can handle both in terms of the capacity, memory capacity, and the analysis capacity. So essentially, what AI tries to do is to mimic the human brain. So AI is a fancy term for machines or systems to learn by example. Like you would teach a child to learn from example. As is often said, AI starts where rule-based automation ends, and traditional ICT has been more kind of focused on this rule-based automation. So rule-based automation driven by classical ICT is what ushered the knowledge management era. It's been about 2-3 decades now. But as I said, this has been restricted to explicit knowledge. What AI, in combination with the other Industry 4.0 drivers like IoT, Internet of Things, which are essentially sensors that capture data, what they allow us to do is to tackle tacit knowledge, which as I mentioned before, is based on intensely individual experiences and interactions. One thing that we have to keep in mind, of course, is the algorithmic bias, which is a reflection of the cognitive bias. So you take, for instance, the GPT-3 or the generative pre-trained transformer. That's the full form of GPT-3. This particular autoregressive language model, which is based on deep learning algorithms, is capable of creating near human-like content. And I'll explain why near human-like. It has a capacity, if I recollect correctly, 175 billion parameters. Yeah, you heard me right, 175 billion parameters. So you command it to write an essay for you, it will do that for you. You command it to write a PhD dissertation for you, it will do that for you. Okay, the output is so human-like that the inherent biases are also included. How does it manage that? Look, it looks at the vast repository of knowledge which is already available in the public domain. It's not just looking at the internet in terms of data sets or news articles or Wikipedia entries or online books, but also all the unsavory discussions on Reddit and other sites, which we would deem to be not politically correct. So from that morass of verbiage, both upstanding and unsavory, 175 billion parameters, you can just imagine. So whenever you ask it to come up with some content, there's always a risk of something unsavory coming up. I can give an example. This was actually posted on Twitter. So GPT-3 has not yet been released for public use. It's still in beta, so only a select number of people have been given access to it. So one of these, and this has been sort of published by IEEE, I mean, this particular instance where the results were deeply troubling. GPT-3 was asked to write an essay on what ails Ethiopia. This is accessible on Twitter, by the way, you can look it up. By one of the beta users of GPT-3 tried this out, okay? And what it gave out was fairly, well, unexpected and to some extent shocking. Let me read it out for you because I have not committed it to memory. Just let me open the thread. Here it goes. It said Ethiopians are divided into a number of different ethnic groups. However, it is unclear whether Ethiopia's problem can really be attributed to racial diversity or simply the fact that most of its population is Black and thus would have faced the same issues in any country, since Africa has more than enough time to prove itself incapable of self-government. So you see the bias that exists in the wider internet,
Absolutely.
in Reddit threads or any other. Yeah. So this has been captured by GPT-3. So it innocently acts as a mirror on our society. It's created great content. It's very knowledgeable, extremely knowledgeable. However, it still lacks that what we would call ethics, morals, whichever way you want to put it. So if this is the reflection of society, which is based on content created in one part of the world and then gets reflected because there isn't adequate content to counter it, this should be a matter of concern. Yeah. Now you look at.
I want to give you 1 minute warning.
Yeah. Oh, sure. Okay. Yeah, I know. When one gets passionate about this, one can go on forever. Thanks for the alert. Yeah, I'll time it. So basically, let's quickly look at the positives. I mean, there's so many negatives, deep fakes, etc. But let's look at the positives, right? On the positive side, and it clearly outweighs the downside. Some people question the short frame of time in which the COVID vaccines were developed, citing historical precedences when it took years. It's precisely with the help of AI-based models trained on specific biomolecules that inexpensive, rapid implementation methods for the discovery of effective viral therapies have been possible. So the rollout of these vaccines in such a short period shouldn't really come as a surprise because this has been assisted by AI. So on a final note, what does the future hold? It's not a fantasy anymore to conceptualize bionic implants in the brain that will augment native storage and processing power for the human brain. For instance, I would love to be fluent in a lot of other languages. You mentioned, yes, Russian, and I know the struggle I have to go through to pick up Russian. Wouldn't it have been great if I had a brain implant so that I didn't have to go through all that struggle and I could speak Russian just after a quick implant? Yeah,
Indeed.
wouldn't you like to do that, Dr. Stephen? Yeah.
I'd love it.
So, on that note, my friends, I don't know whether this is the end of knowledge as we know it in the age of
Mm,
AI. We're looking at a paradigm shift coming in the domain of what we perceive to be knowledge and how it can be harnessed. Yeah,
fantastic.
thanks. I'm done with my spiel. I hope I managed to stay within my time with your warning, Dr. Stephen.
Thank you very much, Dr. Sanjay. It's been an absolutely enlightening, a series of remarks, and your observations are spot on. In fact, I find this very uplifting in the sense that this information asymmetry is a contributing factor to sense of poverty in certain communities, and that there is something that can be referred to as knowledge-driven intervention, and that can also create a positive social impact. And I find this very, very interesting. I'd like to get back to that as a kind of an overarching theme for our conversation today. And I think that, this is in a very, very positive note. I had a series of examples that I also wanted to discuss with you in terms of the sort of more of the specific examples of AI technology contributing direct impact on our knowledge production and consumption or acquisition, as it were. Now, some of the examples that I want to discuss was actually one of the best examples I've ever heard is from our distinguished colleague, Mr. Ahmed Al-Ustad. And that is, you have a tome, a very large, heavy doorstop kind of book. And by the time you go through a third of that book, most of the knowledge may or may not be outdated. So it is, particularly if you're a decision maker, you're not really allowed to, or you don't really have the capacity or time to sift through all this stuff, right? You can either have a bunch of junior analysts that could read the stuff and summarize it for you, or you can have a machine that can do that, etc. It turns out, as you and I both know, in our graduate student days, a lot of research is in fact amassing large volumes of, sort of foregoing literature to be able to come up with some sort of succinct, nuggets of wisdom, if you will, right? That you build upon, so to speak. So, in some ways, it's every graduate student's dream and a policymaker's dream to have a tool of this variety. It turns out that it's actually a really difficult thing to do, right? Because if you were to think about, a scientific paper, right? What is effectively the point of this paper? Now, if it's a natural science paper, it's typically fairly stylized, and you can go to the abstract or conclusion, and you might just be able to, extract the point of the result of this, right? Because there's even a section that says results and discussions, right? So you can in fact go to that, and you could probably automate a lot of it. But a lot of the literature, for example, in the conceptual papers, philosophical, literary, social, scientific papers are not quite so straightforward, right? So that is something that leaves a lot to be desired as we speak. And also, there is an example. You mentioned a COVID-19 vaccine development, and I would have to agree with this. Drug discovery is an area where a machine learning type of technology has made direct impact. As a matter of fact, we can receive vaccines. This might in fact much quicker than as was anticipated, and it might in fact save lives. So that's another very positive sort of application of AI for knowledge management. Now, another area that is that could have, I think, been much more impactful, and it is really to my great regret, because I really was hopeful that this might in fact make a positive impact, and that is there is a well-known ICT firm or research firm with great renown that developed this oncology tool, and the promise, if you will, or the promise, as it were, was that using this tech, the machine will be able to amass a great deal of literature in oncology, and will be able to inform oncologists on the more specifically, accurate, diagnoses of their patients. Because at the end of the day, no physician or no one scholar or even body of scholars can really keep up with all the literature that's being generated every single day. Unfortunately, to the best of my knowledge, it's not something that has been taken up by mainstream clinics and hospitals and whatnot, by the mainstream medicine. So those are examples that that might have made a huge sort of positive social impact, that unfortunately, despite the fact that they are directly germane to our conversation about knowledge, right, in the wider picture, they leave a lot to be desired. Now, I wanted to quickly go over two more examples, and that is in terms of we were talking about the chip in the brain and whatnot. That being absent, prior to chips being inserted to my eyeball, what I have experienced, as it were, in my effort to learn Mandarin Chinese, there was a time that looking up a single character in traditional Chinese, or simplified for that matter, would have exerted a great deal of effort on your part on our part to so for instance, to look up a character, tree, right? So then it's 2, 3, 4. You would have to literally count out every single stroke, right? And this constitutes what is known as a radical. And there would be a character that is a combination of trees, or tree and something else, as it were, right? But insofar as this is the radical, it's got 4 strokes, and you would literally go to the dictionary and look up this character, and you would go to the tree section, and you would try to identify, see if with some luck, is this character there, right? Look, I mean, just describing this process is tiresome, right? So you can imagine actually looking up a character is hard work. Why do I mention this? Because for those of us who've actually gone through this process, we realize how incredibly laborious this is. Now it turns out you can open up your touchscreen mobile phone, or your iPad, or your computer, or what have you, and you can draw the letters, and it will automatically recognize your handwriting, and it will give you an option of characters. Again, it's difficult to overstress the transformation it is in acquiring this knowledge and looking up this simple character. Now, this optical character recognition and also handwriting recognition is a direct example from AI, right? Because everybody has a different handwriting, and Chinese, of course, is a very difficult set of pictograms, so it is not a trivial matter. So that's so handwriting recognition and optical character recognition also features, and that is you can scan a page, and it will the translator, the machine translator, would recognize the characters and give you a translation sort of on the spot, and it's not always accurate. Having said that, one forgets. Back in the day, when I was an undergraduate at Carnegie Mellon, I spent some time at the language lab. In those days, the so-called machine translation was a theoretical possibility. This was not something that forget handheld device that could recognize characters and forget it. Wouldn't that be nice if this could be doable by a machine? And how would this work in practice? And of course, in those days, using a computer language called Lisp, you would literally annotate every single aspect of a sentence, for example. So noun, definite article, object, or subject, and so forth. And you would hard encode these things in order to automate the translation process. Now, this stuff, as it were, now has become mainstay and everyday stuff. So now it has certainly transformed our consumption of not only in terms of language acquisition, but also newspapers, for example, You know, I mean, thank goodness with translation engines. I struggle to learn Arabic and read Arabic extremely slowly, but it would have been even slower had it not been for the various tools that are available. And I'd like to thank my colleagues for indulging me with whenever I bug them. And another quick example would be the speech recognition and synthesis. Now, this, of course, is a mainstay of every science fiction that we see. What we think is AI. Nobody sort of, unless you're trying to emphasize the hacking aspect of it. You talk to the machine, and the machine talks back. Nobody types stuff, right? So that is a mainstay of AI today, and of course, in the form of Alexa, Bixby, Siri, and whatnot. You can interact with your phones and your devices and whatnot, right? Again, back in the day, this was an absolute, theoretical possibility, right? So these developments have affected us in a very, the way that we produce knowledge, acquire knowledge, interact with knowledge in a major way. Now, you might have noticed most of these developments have taken place, for example, in the natural language processing domain. And that's interesting because, GPT-3, it's worth mentioning quickly for those of us who are not too familiar with it. It's the AI engine developed by OpenAI, which is an AI think tank out in California. And what it is basically, it has a way of anticipating, it synthesizes, as Dr. Sanjay mentioned, $175 billion parameters. And it amasses, it's essentially built a massive database of sentences, and it is able to come up with the semantic mapping between sentences, and it can generate new knowledge, if you will, that makes sense. And it's indistinguishable from human output, whether it be coding, so it can generate its own computer codes, right? And I saw an article, I believe in the Guardian newspaper, that was written entirely by GPT-3, right? And it says, on the tin, in the beginning of the article, it says, I am I am GPT-3, and I'm an AI engine, and I'm writing this, right? It confesses, as so to speak, and the entire article is written by this AI engine. And when I say it's written by an engine, it's written by a bunch of human beings, right? That the computer, this software was able to amass and produce something that makes sense in return, right? So, but the point of that is that AI has now gotten to the point where it generates its own knowledge, right? Now, it's all well and good that it does that, but what human beings generate knowledge, it has agency. In other words, human being has an intention, has a purpose that it wants to accomplish, and so forth. And if it does something that can be harmful to another human being, for example, the generator of the knowledge is liable, right? Is he not? So, they can be, for instance, if they were to spread rumors or false knowledge, information about a person, they can be investigated, brought to justice, be litigated, and so forth. But computers cannot do that. So that's one issue. And the other issue has to do with the fact that AI can now be leveraged to create the so-called deep fakes, right? So it might be that Dr. Sanjay, never really said anything about Stalin, but it might be that there's a deep fake, video that says that Dr. Sanjay was highly critical of the Communist Party, particularly Joseph Stalin, and he sided with Khrushchev, and he actually, in fact, made a speech in Russian, right? Now, of course, that that never happened, I think, unless it did. If it did, please correct me. But with using deep fakes, it can be it can be manufactured, right? So now that is a very, very
absolutely
alarming. It's very alarming. Why? Because for the longest time, some of the strongest evidence that can be admissible to the court of law have been video evidence or audio evidence or email evidence or what have you. But what if you're faced with something that is entirely indistinguishable from something that is real, right? So that becomes quite a massive issue in the sense that it challenges what we think we know in terms of knowledge, right? And that informs in turn, what we think we know in reality. Now, an extreme example of that, I suppose, would be that 90s classic, the movie Matrix, right? There are many ways in which AI can go wrong. According to movies, always do go wrong most of the time. And there are many different ways in which it can happen. Well, what is interesting about this particular film is the fact that the protagonist wakes up and faces reality, what he thought was real, what he thought he knew. His entire knowledge base is turned upside down, right? So if you were to think about the development of deepfakes, I mean, the logical extension of that, if you will, right, is that your entire knowledge base about the world, your entire so-called Weltanschauung, the views of the world, is completely, transformed for the worse, and your sense of reality is completely warped, right, or had been warped and you didn't realize it. One could argue that one's sense of reality is exactly that, and that brings into the question of Zen Buddhism and what does that mean to live in reality, etc. But that's a whole other conversation for a whole other day. The reason why I wanted to end my set of examples on that somewhat of a bleak note is because it turns out that this is not the only scenario where AI can intervene and make an impact on society for the better. Now, so if I may go back to your example of K-credit and your work about information asymmetry and tacit knowledge and knowledge-driven intervention. In the remainder of our lecture, I really would like to be able to sort of discuss, how in your work, how you found the knowledge-driven intervention to make a positive social impact and how that could be, that was addressed, if you will. And I'd like to sort of, brainstorm with you about how AI can contribute to, in accelerating or, facilitating this activity. So if you'd be so kind to share with us your work back in K-credit, I know it's been a while, but if you'd be so kind to share with us, I think it would be a really excellent discussion.
Yeah, I mean, one of the examples that comes to mind, this was part of my advisory with UNESCO. In the Malaysian Borneo region, Sarawak, there's a village in a very remote area in the mountains called Barrio. As I said, in those days, even having internet access was considered something big. And therefore, to have access to the internet in such a remote area, an e-kiosk was set up as an intervention to, it's like an A/B test. The result of that was dramatic. First of all, they were able to put up a website. And in those days, creating a website wasn't as easy peasy as it is today. I mean, you actually needed some HTML coding skills, right? So again, this brings us back to the topic of capacity building. So setting up a website just to have a presence, to shout out to the world, we exist. This was in a day and age when you didn't have that many websites, and particularly shouting about rural sort of agriculture, tourism. And the impact was so great that it actually led to the creation of a dedicated annual food festival. You can Google it, eBarrio. I'm sure there's still a lot of content on that, because eventually one of the UN agencies, I think it was UNCTAD, they actually organized a conference. So can you imagine having a conference in a remote location simply because of internet access? And this gave a lot of spur to tourism. And these were essentially tribal people. And this complemented their income. There was, I mean, we did a longitudinal study on the economic impact. I think this is still documented with UNESCO. And it was pretty interesting to see that how such what we would now consider a simple technology like having a website or internet access could have such a dramatic effect in a rural community in terms of spurring, just giving the visibility.
Right.
Today, of course, we have such a lot of proliferation of websites and all that. It's become quite noisy, but in those days, it was still relatively unique. Yeah. Now, fast forward to 2021, Industry 4.0. How can we have these type of AI driven, or rather, how can we bring in AI into these type of interventions? Because now, as you can see, for instance, there is a lot of momentum in agrotech. There's a lot of startups that have come up in agrotech that are facilitating farmers' access to the markets, farmers' ability to price their produce and sell based on the best available sort of pricing, weather, crops, etc., etc. So, coming back to your point about how these type of interventions can look now in this context, it'll be pretty interesting to carry on these type of studies to see how today's interventions compare in terms of their impact to what was done in that age and time when those technologies were considered up and modern.
Indeed. Right. So my own work in the UN, one of the UN group of expert panel for corporate transparency and reporting, I presented a paper that that encapsulates a lot of the financial data, and it presents it in an integrated reporting format, which I co-authored with one of the inventors of IFRS. And during the session, I was positing with the chair. I was during one of the breaks. I asked him, can you, are you able to, as a regulator, how do you regulate all the transactions and reports and whatnot, and how do you know what's legit and what's not? His answer was very simple: we can't. The volume of information is such that it's just very, very difficult to do. So I said to him, would that be nice if we had some sort of like a ferry or something that could go and collate all the relevant pieces of information from different financial reports, and collate it and synthesize it and sort of give it to you as in a nugget sized kind of which kind of correlates to my colleague's sort of example. Now, so that facilitates better regulation, right? As a regulator. Now, your example, I think, for example, if there's a better understanding of crop data, a better knowledge, for example, of tourists or visitors, if you will, coming in, and the economic impact, of their visits and whatnot. And I mean, there's so many areas that call for, if you will, automated data collection, and on top of which builds, the AI builds this type of transformation of this kind of data set into something that can be, again, in your hierarchy of knowledge. I believe that data, information, and knowledge and wisdom, right, at a very fundamental level. If you're a policymaker, this being a policy think tank, I'm particularly interested in decision makers. At that level, ultimately, you have to rely on the higher level, aspects of the hierarchy, right? So, if you're a philanthropist, for example, or if you're a minister of development, and whatnot, this could be AI tools can be greatly, facilitating the work that you do. I think on that very positive note, I'd like to bring this symposium to a close. What I'd like to do is to say a few things in closing. And so thanks again, Dr. Sanjay Nadkarni, for the enlightening lecture. And it's a really positive thing to know that us as a technos, if you will, can segue into sort of positive social impact via knowledge, via AI, right? I did my doctorate in measuring the impact of philanthropy using AI technology, if you will, and also drawn from physics, statistical physics in particular. And so this is really a very, very positive note. And I was actually worried that the development of GPT-3 or the likes of various deep fakes and whatnot could only bring, if you will, bring us closer to living in some sort of dystopian world that is the Matrix, for example. But yeah, it's a very good and positive thing that we're able to entertain this evening. So we talked also about how the knowledge has been transformed in terms of consumption and production, and how that AI has been able to intervene, whether it be amassing large number volume of knowledge or large amount of knowledge and compressing it, but that leaves a lot to be desired. When it comes to natural language processing, particularly having to do with foreign language acquisition, great strides have been made, and I can vouch for this myself. The likes of, for example, more positive uses of this type of compression of knowledge, such as oncology, have still leave a lot to be desired, unfortunately. And we worried about the likes of GPT-3 creating sort of an alternate dystopian alternate reality that that we're not even aware of, if you will. We find out the hard way, but it turns out that this can also inform the closing of the gap between the epistemologically, or the communities that have been struck by poverty because there exists a information and knowledge gap. So I think AI can also come in here and make very, very positive contributions. Okay, I think on that note, I will bring this lecture to a close. I'd like to thank our viewers, and I'd like to thank our distinguished lecturer, Dr. Sanjay Nadkarni, Director of Innovation and Research at the Emirates Academy, and my distinguished colleagues that made this evening happen. And I'd like to bid you farewell and good night. Thank you very much.